Topic to 8-bit number addition with carry. Teammates are myself, Chandana, Prerana, Pooja. Next, content. Introduction, objectives, problem statement, implementation, algorithm, assembly code, output, conclusion. Introduction. Assembly language programming allows direct communication with a microcontroller hardware using symbolical instruction instead of binary codes. It provides precise control over CPU registers, flags, and memory operations, making it circular for embedded systems and real-time control application for the 8051 microcontrollers. Assembly language implements manipulation of internal registers, performing arithmetic and logical operation and input-output device efficiency. In such cases, the carry flag became set to 1, indicating an overflow into the next higher bit. This carry can be stored separately or added into subsequent multi-bit addition. The status of the operation is reflected in the flag register, which applied automatically after the execution of the addition instruction. Next part, objectives. To design and implement an 8051 assembly program for adding two 8-bit numbers stored in memory, to store and the sum carry separately in distant memory location, to analyze how the accumulator and flag operate during arithmetic operation, to visual instruction executing using a sequence diagram, to study accumulate operation, understanding the role of the accumulator in performing arithmetic operation and temporarily holding data during execution, to observe flag register behavior, analyze how status flag are affected after the addition in the instruction is executed, to develop understanding of the instruction sequences, learning how instructions are executed in sequence to perform arithmetic operations and manage memory data flow efficiency, to apply addition in real world sensors related the concept of two real-time applications like digital meter recording, sensors, data processing, and in embedded system arithmetic operations. Next, continued well by Chandana.
So the problem statement is add two numbers scenario data. The first number at the memory location 70H, second number at memory location 71H. Task to add both numbers and store the sum at 72H. Next problem statement store carry. Scenario of addition generates a carry task to store the value at 73H. Next, so the implementation. First, we have to load the accumulator with the first number from memory location 70H. The accumulator is the main register used for arithmetic operation in 8051. So the next we add the second number which is stored in the memory location 71H to the accumulator. The result then the result of this addition is stored in the memory location 72H. Then after that, we check the carry flag. If the sum goes beyond 8 bits, a carry will be generated. If the carry equals 1, we store 0H at memory location 73. Otherwise, if there is no carry, we store 00H. Finally, we end the program. Next, so the code. So, the first line 0 org means the program starts from the memory address 000H. Then we use move a 70H to load the first number into accumulator. Next add a 71H adds the second number from the memory location 71 to the accumulator. After addition, we store the result back to the memory move 72H. A. The instruction JC carry set checks if carry is generated. If there is no carry, we clear the accumulator using CRL, which makes it 00. Then, if the carry is present, then it stores in another, but if no carries it doesn't store. So the next sjmp means it means jump. So after solving all this loop, the code next jumps to the next line of execution. So the next line is end, so the program ends. So the next output of this program is this. Then next will be continued by Prerana.
Problem statement 2. So, store carry scenario task. If the addition results exceed 255 FFH, carry flag CY becomes program checks CY flag using JC instruction. If CY is equals to carry stored as 01H at 73H, if CY is equals to 0, carry stored as 00H at 73, it means when two 8-bit numbers are added in the 8085 microprocessor, the result might be greater than and what 8 bits can hold in case a carry is generated. This carry is stored in the carry flag CY of the flag register. So, after performing addition, the program checks whether the carry flag CY is set or not. If CY is equals to 1, it means the result exceeded 255, means overflow occurred. If CY is equals to 0, it means no overflow happened. So, um, next, the program then stores the carry information at memory location 73H. If CY is equals to 1, store at 01H at 73H. If CY is equals to 0, store 00H at 73H. So let's see how it works. Add two numbers, check the carry flag using jump if carry instruction. Based on the result, if carry is equals to 1, move 01H to 73H. If carry is equals to 0, move 00H to 73H. So now let's move on to the problem statement 3. So as you can see the sequence diagram, uh, sequence diagram, it shows order of operations in the program. It helps us to understand data flows, how instructions are executed. And start from here, the program begins and move a 70H. It loads the value stored at the memory 70H into accumulator A. Add 71H, add the value from the memory 71H to A. Now the next one, move 72HA, means it stores the addition result into memory location 72H. Now check CY. It sees if carry CY is 1 or 0. So if CY is equals to 1, then it moves 01H to A and store A 01H at memory 73H. If carry is equals to 0, then move 00H to A, store A at memory 73H location, and it finishes the program. So the next part will be continued by Pooja R.
Problem statement 4. Memory operation explanation. The accumulator A is used to store the first number and also the result after adding two numbers. Example, data from memory 70H is loaded into A. Then A add data from 71H and the result stays in A. After addition, the carry flag CY shows if the result is too big, more than 255. CY is equals to 1, overflow acute, where the sum is greater than 255. CY is equals to 0, no overflow, sum is less than or equals to 255. So this image explains how the accumulator and the carry flag help in performing and checking addition operations in the 8051 microcontroller. Next slide. Conclusion. This program shows how to perform a basic 8-bit arithmetic addition operation using the 8051 microcontroller. It explains how the accumulator stores data and how the carry flag works when the result is too large. It also teaches how to use registers and memory efficiently for data transfer. The main learning includes checking flags during arithmetic, using direct addressing to save memory, and understanding how instructions run step by step, and how branching, jumping in program flow happens. Thank you.